Hey there, Algebra 2 students. I want to go over some questions from section 9.8. So let's get started here. When they say find the exact value of the sine of 23 pi over 12, you need to say to yourself, what is this lesson all about? We're using the sum and difference formula, so let's see if there's a way I can break this into a sum or a difference that will make this easier to evaluate, because I need to find the exact value, not a decimal value. Do you hear me? Not a decimal value. Okay, so when I see 23 pi over 12, the first thought was, 20 pi over 12 and 3 pi over 12. Will that work? Are those, when I simplify those, are they values that might appear on my unit circle? So yeah, actually 20 pi over 12 simplifies to 5 pi over 3. That's on the unit circle. And 3 pi over 12 simplifies to pi over 4, which is also on my unit circle. So we're going to use the sine of a sum formula. So sine of a plus b equals sine of a cosine of b plus cosine of a times the sine of b. So we'll use a simplified term, so sine of 5 pi over 3 times the cosine of pi over 4 plus the cosine of 5 pi over 3 times the sine of pi over 4. Well, the sine of 5 pi over 3, according to my unit circle, sine is going to give me my y-coordinate, so that's negative square root of 3 over 2, right? Negative square root of 3 over 2. The cosine of pi over 4, you should be familiar with that one by now. That's the square root of 2 over 2. The cosine of 5 pi over 3, if we're looking at our unit circle, that's 1/2. And the sine of pi over 4, you should know that that's the square root of 2 over 2 already. So let's multiply this out. We get negative square root of 6 over 4 for this term, and then plus the square root of 2 over 4. And so I wrote it as a single fraction here with the negative square root of 6 in the front. But you can write it this way, the square root of 2 minus the square root of 6 all over 4. Okay, let's take a look at number 5. It says sine of a plus b, well, evaluate sine of a plus b, given that cosine of a is 4/5 with a between 0 and pi over 2, and sine of b is negative 15/17 with 3 pi over 2 less than b less than 2 pi. Okay, if I were seeing this for the first time, I might have a minor panic attack. Yeah, but it's not that bad. I promise. We can get through this, right? When you know that cosine of a is 4 over 5, remember cosine is adjacent over hypotenuse, so I'm going to draw a little reference triangle here. Here's my little angle alpha. My adjacent side is 4, my hypotenuse is 5. I needed to find the side opposite of that, so I did a little Pythagorean theorem. A squared plus 4 squared equals 5 squared. That's 16 and 25. Subtract 16 from both sides. A squared equals 9. Square root both sides. A equals 3. Now, if you remember that there's a 3, 4, 5 right triangle, you can save yourself those steps. 3, 4, 5. Right triangle. Okay, so that means that the sine of alpha is 3/5. You do not need to actually find the angle alpha or the angle beta or b, a or b. You just need to find the sine of the angle. So in this case, sine of a is 3/5. Over here, sine of b equals negative 15/17, and they're telling us that the angle b is in the 4th quadrant, right? That's what all of this means. It's in the 4th quadrant. So I start off with my angle b, the opposite is 15, the hypotenuse is 17, and I need to find this side, right? So I set up the Pythagorean theorem, a squared plus 15 squared equals 17 squared, a squared plus 225 equals 289, subtract 225 from both sides, a squared equals 64, square root both sides, a equals 8. There you go. So the cosine of b will be 8/17. And it's positive because we know that all students take calculus. And so cosine is positive in the fourth quadrant. Okay, since we have these four things, right, we can use our formula for the sine of A plus B, right, sine of A cosine of B plus cosine of A sine of B, and plug them in and evaluate. So sine of A is 3/5, cosine of B is 8/17, plus cosine of A is 4/5, sine of B is -15/17. You multiply those together, you get 24/85 minus 60/85, and that equals -36/85. Boom. See, that wasn't so bad. Okay, we got a couple more. Oh, this one's fun. All right, you've got sine of x minus 3π/2. We're going to use the difference formula for sine, right? Sine of A minus B is sine of A cosine of B minus cosine A sine B. And A will be x and B will be 3π/2. So I'm just going to plug those into the formula, the x and the 3π/2. Then I need to evaluate, right? So sine of x is going to stay sine of x. But what's cosine of 3π/2? Check your unit circle. When you check your unit circle, you should find that cosine of 3π/2 is 0. Boom. That term will disappear, right? Then you've got cosine of x times the sine of 3π/2. The sine of 3π/2 is -1. Check your unit circle, right? And a -1 times this minus sign out in front will make a positive cosine of x. So cosine of x is your answer to, this is now question 3 from section B of 9.8, right? And I've got one more for you. It says, what are the solutions of the equation 2 sine of x minus 1 equals 0, for 0 is less than or equal to x is less than to 2 pi. So that's the whole circle, right? One complete revolution. So I don't know if you've seen any examples of this actually. So we'll take this. We're going to get the sine of x by itself. So I'm going to add 1 to both sides. So I have 2 sine of x equals 1/2. Nope, equals 1. And then I'm going to divide both sides by 2. So I get sine of x equals 1/2. And then I have to say to myself, what angles have a sine that is equal to 1/2? Like the sine of what angles is 1/2? And you can look at your unit circle and remember sine is the y values. And there are only 2 angles, and they are π/6 and 5π/6. If you typed into your calculator sine of π/6, you would get 1/2, assuming your calculator's in radians. If your calculator's in degrees, it won't say that it's 1/2. It will give you something else, and that would be bad. So make sure you're using the right units, whether it's radians or degrees. And sine of 5π/6 is also 1/2. All right, that's kind of a lot for one video. I hope this answers some questions about section 9.8. I hope that you are all well. We'll see you next time.